Hi, in this video we're going to introduce the idea of top-down design and decomposition in Karel. So, we introduced functions recently, and as a reminder, we use functions for several important reasons. First, to break down our program into smaller parts. Second, to avoid repeated code. And third, to make our program more readable. We're going to explain top-down design and program decomposition and how we use functions to solve these problems. So what is top-down design and what is decomposition? Well, let's think about it this way. Let's say you're starting off with some really big problem that you don't know exactly how to solve. Well, then the first thing you do is you break it down into several smaller problems. And now those problems are a little bit easier than the big problem. And then from those smaller problems, you break it down into even smaller problems. And you keep doing this to a point where the problems are so small and so easy to solve that you can just go and do it. So let's look at another example. Let's say you wanted to make a movie. Well, the problem of making a movie is very big, but you can break that into several steps. You need to write the script. You need to hire the cast and crew. You need to film the movie. You need to go edit the movie. But these in themselves are each big problems. And the problem of filming the movie we can break down into filming scene 1, and filming scene 2, and filming scene 3. And so we start with a big problem and we decompose the problem into smaller problems that are easier to solve. The reason this is top-down design is because we're going from the top down as opposed from the bottom up. We're starting with the big problem and then breaking it down into smaller problems. So in this video, what we're going to do is we're going to solve the problem called hurdle Karel. So Karel starts in this top world, all the way on the left facing east, and has a series of 2 hurdles in front of him. And we need to jump over those hurdles, and then finish this race. So let's go into our code editor and write this program. Okay, so we'll start with our start function. And what we're doing, since we're going to use top-down design to solve this problem, is we write the functions that we need to just solve this problem. So the first thing we want to do is we'll run to the hurdle. Now, Karel doesn't know how currently to run to the hurdle, but we'll define that function. So first we need to run to the hurdle, and then we'll jump over the hurdle. And then what we need to do is we need to run to the next hurdle, and then we'll jump over that hurdle, and then we'll run to the finish. And so our start function reads like a story. The function names are clear, so it shows what we want to do. So next, we just have to write these functions. So let's go function run to hurdle. Well, running to a hurdle, what we need to do is we need to move 3 times. And so if I run this, the program won't run because we don't have all of our functions defined. So what I'll do here is I'll comment out, I'll say, let's ignore some of these functions for the time being. So we'll run the hurdle, great. Now, the next thing we need to do at this point is we need to teach Karel how to jump a hurdle. So we say function jump hurdle. And what we want to do here is, well, we want to turn left, then we want to move, and then, well, we want to turn right. But we have to teach Karel how to turn right, so we'll say function turn right. While that's turning right is turn left 3 times. So let's see where this leaves us. Oops, we have to remember to bring back in jump hurdle. Okay, so we've turned right, and now we need to move, and then turn right again. Let's see where that leaves us. Okay, and then we'll move, and then we'll turn left. Great, so now we've taught Karel how to run to a hurdle, and then taught Karel how to jump a hurdle. And now we can continue to use these functions to avoid repeated code. We had this problem of running to the hurdle. It's the same for the first 2 hurdles. We have the problem of jumping the hurdle. It's the same for each hurdle. So we use a function to solve this problem. So I'll bring in these 2 lines, and now we see Karel runs the hurdle, and then we're almost done, jumps 2 hurdles. We just have to run to finish. And so we say function run to finish, and to do that we say move 4 times. Let's run that. And there we have it. We've solved a tough problem by breaking it down using top-down design. We decomposed this problem into smaller parts that were easier to solve, and then wrote functions to teach Karel how to do these new things.